So this is the first lesson in the Functions and Graphs section of our Higher Maths course. We're going to look at sets and set notation. So a set in mathematics is simply a well-defined group of items, objects, in our case quite often numbers, and you need to be familiar with some of the basic definitions used in set theory. They apply quite a lot to functions. So the members of a set are called the elements of the set, and we use special brackets to enclose those elements. What we'll do first of all is look at some notation and an example in each case. So if we look on the left hand side for our notation, first of all we can talk about elements that are members of sets. So this symbol means is a member of, and clearly 3 is a member of the set of prime numbers. 3 is a prime number. We can also say that something is not a member, so we could say that 4 is not a member of the set of prime numbers. We can have such a thing as a subset. This won't come up terribly much in higher maths, but this symbol means it's a subset of. So 2 and 3, that set of numbers is a subset of the prime numbers. And if we have our set brackets with nothing inside, that means it's an empty set. So the set of even prime numbers greater than 2 is an empty set. There are no even prime numbers greater than 2. And then this symbol here means for all values, for all or any values of. So x squared is greater than or equal to 0 for all values of x, where x is a member of the real set of numbers. So that should really just be for all values of. There are some standard number sets that we need to note. So we start with the natural numbers. So this doesn't include 0. It would have been the initial counting numbers for humans. Then if we add 0, we have what we call the whole numbers. If we then introduce negatives, but still using positive or negative whole numbers, then we have what we call the integers. We denote that with the letter Z, from the German word for number, which is Zahl. And if we then think about including fractions, then we have what we call the rational numbers. So we have the letter Q, all numbers that can be expressed as a fraction, a over b, where a and b are integers. Clearly that includes integers and whole numbers and natural numbers. They can all be written as fractions. And if we then think about numbers that can't be expressed as a fraction, we have what we call irrational numbers. So here's where we might include numbers like pi, the square root of 2. These are all irrational, so we call the rational and irrational real numbers. The diagram above shows the relationship between all of these. So we have our whole numbers, a subset of the integers, which is a subset of rational numbers, and all the rational numbers and irrational numbers make up real numbers. So you can think of real numbers as just all the numbers to the left and right of 0 on the x-axis. Sometimes we'll use set notation like this to show that they are subsets. So if we think about functions and a definition for functions, we can look at that now. So in mathematics, a function can be thought of as a rule that associates each member of one set, we'll call that the domain, with a member of another set. We call that set the range, a bit like our x and y values. So we say that the function f maps each element in the domain with one and only one element in the range. Functions can be one-to-one, many-to-one, but they cannot be one-to-many. We'll talk about that idea in this course. You can see our diagram here where we have x1 being mapped by the function f to y1, whereas x2 and x3 are both being mapped to the same place, y2. So this would be a many-to-one function, but you'll see that it's not one-to-many because each element is going to just one place in the range. So we'll look at diagrams like this in a bit more detail, but it's an important definition to note that we cannot have a one-to-many function. Okay, let's look at some examples. So first of all, an example of a many-to-one function would be the function which maps x to x squared. And we write this as f of x equals x squared. Our domain can be any value of x. We know that any number in the real set of numbers can be squared. But what can we say about the range? To identify the range, we need to focus in on the domain. So let's say that we take our domain as just the integers -3, -2, -1, 0, 1, 2, and 3. If we find the value of f for each of these values, so f of -3, f of -2, etc., by putting them into the function, then we are actually finding the values which would exist in the range. Remember, we're mapping from the set, which is the domain, to the set, which is the range. So we can see here, and you can pause this video if you wish, that our range is simply the numbers 0, 1, 4, and 9. And we note that all the values in the range will be positive. If you square any number, positive or negative, in the real number set, you get a positive value. We can now think about sketching this function, with a graph. We can do that by plotting the 7 points that we've looked at, so -3, 9, -2, 4, and so on. And if we do that in a quick sketch, we'll see that we should get a graph something like this. We know that a function f of x equals x squared is a quadratic, it has a parabola as its curve, and this is the function f of x equals x squared, where x is a member of the real number set. So you'll be able to look at questions that allow you to find the range for a particular function. If we look at another example, we want here to list the sets defined by the following. So first of all, for part A, we can see that we have T, which says that x is such that x is greater than or equal to 0, less than 3, and x is a member of the natural number set. So if we think about this carefully, what are the numbers that would be in that set? What are the elements of that set? Well, the only natural numbers which are greater than or equal to 0, but less than 3, would be, and if you can get the answer, you're doing well, it would be 1 and 2. 0 is not a natural number, but 1 and 2 would be. Looking at part B, we want Q, which is the set y, such that y squared plus 4 equals 0. And y has to be a real number, member of the real number set. Now, if you're squaring a number, then it's going to be 0 or greater, but then if you add on 4, it's certainly not going to equal 0. So in this example, Q is actually an empty set. Any real number squared will be 0 or greater, plus 4, it will now be 4 or greater. In the last example, we have h of x equals x cubed, and we're given a domain here. X is between -3 and 3, x is greater than or equal to -3 and less than or equal to 3, where x is any real number. So to identify the range of h of x and express it in set notation, we might not actually need to evaluate each and every integer value from -3 to 3, but it might be an idea to do something like that again. We could actually also here just look at h for -3 and h for 3 to get the idea of the range of values. But I'm just going to do the same as we did before, check some integer values. Here we're not told that x has to be an integer. It can be any real number in that range. But again, for each of these, we can find the element that would be in the range. So -8 cubed, -1 cubed, and so on. -2 cubed, which is -8. So here we have our values. Again, pause the video if you want to check where these numbers came from a bit more carefully. But if we do that, we see that the range of values is actually between -27 and these values are really all the way up to 27. These values are not the entire range of values, so we have to be more precise here and say that the range, in set notation, we could write that the range is, let's say y, such that -27 is less than or equal to y, and that's less than or equal to 27, where y is any real number. So that covers the range for that particular domain. It's now time to get some practice with these ideas. If you are following the TG textbook, then page 21, H3.1, questions 4, 5, 6, 8 and 10 would be good. For those looking at the Heinemann textbook, I would recommend page 23-24, exercise 2A and 2B. Please remember there are other lessons in this topic available on my YouTube channel. This is lesson 1 of 4, so please check out the others, and with some hard work you'll be well on your way to an A.